Hi, welcome to my capstone presentation, The Bent Wheel. Let me tell you a story. Brooke Warren was driving along on her way to a backpacking trip. She was starting to get sleepy and, like a good driver, decided she would pull off at the next pullout to take a nap. Ahead she saw a cyclist and gave him a wide berth, but her eyelids drooped momentarily on her way back into the lane and completely missed the cyclist ahead of the one she had safely passed. Thankfully, the cyclist she hit did not die, but she starts her story off by saying, "A few years ago, I crashed into a road biker during a near-fatal lapse of attention. I'm here to tell you that you could be that driver too. I share this not to scare you, but to bring attention to the grave situation at hand. We might think we are the most attentive driver out there and never have intentions of harming anyone, yet something like this could happen to anyone." According to Transport Reviews, cycling safety is generally regarded as an under-researched topic. So what better topic to research for my capstone than this? Hi, I'm Lacey, and my passion for design research and my unique position as both a cyclist and motorist led me to researching cycling safety as my capstone. I've broken my capstone down into 6 parts. Congratulations, we've already made it through the introduction. Next we'll cover motivations, research, diving a little deeper into my research, then I'll cast a vision, and finally I'll recap. So let's take a look at my motivations for this project. First off, more than 2 cyclists die every day in the United States alone due to motorist crashes. This isn't even including injuries. That's at least 730 people riding bicycles dying in the US each year because they were hit by a person driving a vehicle. Often, when a cyclist dies in a motorist crash, their bike is painted white and is left at the scene as a reminder, called ghost bikes. This shouldn't be happening. There are so many people involved in this system. The primary are cyclists and motorists. These stakeholders are people who impact the cyclist in the crash, such as other cyclists on the ride, family members, the cycling community, hospitals, emergency responders, and more. Here you can see the stakeholders who impact the motorist in the crash, such as passengers in the vehicle, family members, and the justice system. Highlighted in blue are the stakeholders who have indirect impacts on the other stakeholders. People in this group include city planners, advocacy groups, therapists, and more. Highlighted in red are the tertiary stakeholders, local businesses and residents, along with pedestrians. In the 1890s to the early 1900s, it was mainly cyclists advocating for better roads, not motorists. It is cyclists we have to thank for our paved roads. Over the years, of course, as cars came onto the scene, cyclists were pushed out of the frame. The world, but more specifically America, became autofocused. Cyclists have always been allowed on roads, but now there is a general disdain between cyclists and motorists. There are many misconstrued ideas of cyclists out there, such as roads are designed for cars. Well, as we just discussed, cyclists have always been allowed on US roads. One cyclist went as far as to say, "Don't ever say I died doing what I love. I have no affection for being pulverized by a 4,000-pound SUV. Another wrote, "The driver who hit me got away with a 2-year sentence, and I got a life sentence," referring to his life paralysis. Cycling is not going anywhere, so we need to fix this problem before more people are hurt. All of this research led me to my project brief. How might we make life safer for road cyclists? Specifically targeting defensive cycling, communication, road design, and something called inattentional blindness, which we'll dive into later. The steps I went through were research, displaying my findings, highlighting certain issues, and identifying opportunities for change. Next, we'll begin to take a look at the research I conducted. The research methods I used were traditional means, surveys, and interviews. Taking a look at the traditional means, I read many articles, used mind maps and system maps to organize and categorize the information I had found. A good deal of my traditional research took the form of competitive sets. I looked at cycling infrastructure, unique cycling infrastructure worldwide, and cycling products. Taking a look at the cycling infrastructure, we have many types. A few important ones are sharrows, which are lane markings on the road, suggesting motorists should share the lane with cyclists. Conventional bike lanes are placed next to a motorist lane and have a small paint stripe separating the 2 users. Contraflow lanes are placed on motorist one-way streets, but the cycling lane turns it into a 2-way street. Two-way cycle tracks are placed between motorist lanes and the sidewalk with a buffer, creating a type of bicycle road. Protected intersections are multi-layer intersections for many types of users. Here, protected cycle lanes flow into their own turn lanes. Within these, I compared many types of information. But let's take a look at some of the specific insights I pulled from this. Sharrows are best placed on quiet streets with tree canopies as they slow drivers down. Conventional bike lanes are the most commonly used ones in the US, even though they are not the safest option. Contraflow lanes alleviate the problem of connectivity and cyclists accidentally riding the wrong way or on the sidewalks. Two-way cycle tracks provide more of a problem with crossing driveways and minor streets. Lastly, protected intersections focus on not mixing types of traffic and instead focus on improving visibility. However, they are highly intense to implement. Taking a look at the cycling infrastructure worldwide, we have the Nelson Street Cycleway in New Zealand, the Barrencools in the Netherlands, and lastly, the Danish Green Wave. Within these, again, I compared many things, but let's take a look at some of the specific insights I pulled from this. The ability to reuse a highway off-ramp and connect paths citywide in New Zealand, creating physical hierarchy in the Netherlands by raising paths for cars and lowering the paths for bicycles, and lastly, the Green Wave used lights and sensors to reduce the number of stops cyclists have to make at red lights in Copenhagen, lessening the danger of intersections. Taking a look at cycling products, we have Cannondale Smart Sense, Revo Lights, and Light Spurs. Within these, I again compared many features, and even more. From all of this, my key insights were: Smart Sense was the only integrated piece I found, and also the most comprehensive, with auto-adjusting lights based on the time of day and the distance of the approaching vehicle. Revo Lights gives the motorist 360-degree visibility of the cyclist. And Light Spurs creates visible motion on the heels. After some competitive set research, I created a survey to get insights from cyclists, motorists, and those who are both cyclists and motorists. My survey answers came from all across the world, with most coming from the Midwest. So I decided to focus my research on Ohio, as I am currently living in the area and a good deal of my responses came from Ohio or nearby states. Pictured here are 100 out of 472 responses from people who are both cyclists and motorists. They value communication, making drivers aware of cyclists, having enough room, slower speed limits, eliminating distracted driving and distracting noises, connection between cities, physical separation, and they fear merging with cars. Pictured here are 75 responses from motorists and how they view driving on the road with cyclists. They are concerned with passing cyclists safely, worried about the danger, overall they dislike it, some of them want to make sure the cyclists are safe, some don't know what they are allowed to do, some worry about the visibility of the cyclist, and others wish that they would just ride on the sidewalk. Lastly, I conducted 3 interviews with cyclists. Dan, who is a competitive cyclist and is now a paraplegic due to a cyclist-motorist crash this summer. Mary, who has ridden for fitness for years, and Mike, who before COVID rode his bike to and from work 20 miles each way. All of this information helped me create my user personas: the competitive cyclist, the cyclist who rides for fitness, recreation, commuting, and the motorist. Adam is a competitive cyclist. He only rides in a group or by himself, never on the sidewalk, and averages 41 to 50 miles per ride. He knows most things about riding on the road, and he is confident about his abilities. His preparation process is pretty thorough. He's motivated by racing and speed, and his main frustrations are not being visible to cars, cars passing too closely, and going through intersections. He likes to ride on back roads, busy main roads, and light main roads. Cecilia is a fitness-oriented cyclist. She typically rides with a couple other people or by herself, and averages a few less miles than Adam. She is motivated by exercise and the challenge, but her frustrations are not being respected by cars and cars passing too closely. She likes riding on back roads and light main roads. Sophie is a recreational cyclist. She typically rides with a couple other people or in a group, and often on the sidewalk. She knows some things about riding on the road, but she's not very confident about it. She is motivated by hanging out with friends, and her main frustrations are the lack of protection on the road and difficulty navigating. She likes to ride on residential paths, downtown, and light main roads. Damon is a commuting cyclist who commutes from Franklinton to OSU's campus. He typically rides by himself and rides 20 miles both ways. He is motivated by being environmentally conscious and getting exercise, but his main frustrations are inconsistent roads, cars passing too closely, and the lack of respect. He rides on residential roads, paths, downtown, busy main roads, and light main roads. The motorist does not know much about driving on the road with cyclists and does not enjoy it much. The motorist is motivated by getting from point A to point B as quickly and as seamlessly as possible, but his main frustrations are being interrupted and wasting time. So after getting a look at some of my preliminary research, let's take a deeper dive into that research and how it affects people. For the competitive cyclist, his journey from preparation through light main roads to busy main roads and back roads is fairly low stress until he encounters intersections and worrying about his lane position on busy main roads as well as passing distances on back roads. For the fitness-oriented cyclist, her journey from preparation through light main roads and back roads is fairly low stress until she encounters intersections, lane positions, and passing distances. For the recreational cyclist, her journey from preparation through residential roads, light main roads, and downtown roads is more stressful. To her, there are so many different things to pay attention to, and yet she's still trying to enjoy her ride. For the commuting cyclist, his journey from preparation through residential, paths, light main roads, downtown, and campus is fairly low stress until he encounters intersections and driveways. For the motorist, his journey on all the different roads is on average a higher stress level than the cyclist's. Some of his pain points within these areas are interruptions to his speed, looking for cyclists when turning, figuring out how cyclists fit on the road, communicating with the cyclists, and understanding the many moving pieces. From all the personas and their journey maps, I condensed it into their desired experiences while riding and driving. Overall, the competitive cyclist wants to improve their ride. The fitness and recreation-oriented cyclists want to enjoy their ride. The commuting cyclist wants to make the most of their time, and the motorist wants to get from point A to point B. On the surface, all you can see is the conflict between cyclists and motorists, but underneath that is so much more. One step underneath this is patterns of behavior, which is where defensive cycling and communication fall. Defensive cycling is the act of always being aware of what is going on around you and putting yourself in the best possible situation for your safety, as well as always expecting the unexpected. The communication process between motorists and cyclists is imperative and can be done through symbols, signs, and behavior. The next chunk underneath this is system structures. Road design falls under this category. It includes many moving parts that must be considered, such as intersections, speed limits, spacing, cycling infrastructure, types of vehicles, laws, users, budget, and locations. And lastly, mental models. Inattentional blindness is the largest and hardest subjects out of these to fully understand. It is defined as a failure to notice unexpected but perceptible stimuli in a visual scene while one's attention is focused on something else in that scene. This phenomenon occurs even when items are visible for several seconds. Each of these sections I then put into a systems map with all of the research I had collected on them. After going through all this research, I highlighted key aspects which I used to cast my vision for how this research could be used. Here, the problem is visibility on the road. It's important to use the proper gear and know that people are more likely to see animate objects versus inanimate objects. Here, the problem is a lack of communication. It's important to not send mixed signals and recognize that you can't expect drivers to communicate effectively if they're not being taught in the first place. Another problem is inconsistent reactions. It's important for cyclists to act as cars and know when to control their lane. It's also important for road design to promote these consistent reactions. Here, the problem is a lack of traffic calming. It's important to note that the risk of serious injury or death increases significantly when the speed limit is raised. There is a greater difference in cycling and vehicle speeds in suburban areas, which is tied to open roads being worse than intersections. Here, the problem is perceiving sidewalks to be safe. Some of the key points are making sure cyclists know to behave like cars, that they're not meant for sidewalks and it isn't always legal. Besides, it can be extremely dangerous as motorists are not always looking for a fast-moving vehicle crossing the driveway. Here it's important to note that intersections are dangerous. There are many problems such as turning vehicles, car doors opening, and rear ends. Another problem is a high visual attention load. Some of the key points are reducing diversions of attention, bringing attention to critical information, and most importantly, is knowing that looking is not always the same as seeing. And lastly, dehumanization. More aggression leads to dehumanization, which is seeing cyclists as less than human. Recognizing that people are more likely to notice something meaningful to them, such as a name or a face, is important. So let's take a look at how all this research could be used. Here are those 8 major takeaways that I just covered, which I then turned into many how might we questions. I narrowed these how might we questions down, and each major takeaway turns into a how might we question. Visibility on the road turned into how might we make the bicycle the instruction manual on visibility. Lack of communication turns into 2 how might we's. 1, make the cyclist and motorist communication a universal language like math and music, and 2, allow the car, bicycle, and road infrastructure to communicate. Inconsistent reactions turns into how might we design a cyclist infrastructure that elicits a consistent immediate reaction. Lack of traffic calming turns into how might we create traffic calming measures in wide open spaces. Perceived safety of sidewalks turns into how might we provide road space with the same perceived safety value as sidewalks, but actually safer. Dangerous intersections turns into how might we make intersections safe for turning. A high visual attention load turns into how might we help the brain decipher critical information from the rest of the chaos. And lastly, dehumanization turns into how might we make the cyclist meaningful to drivers. All of these final how might we statements I turned into vision boards. For the first one, I asked myself, how might we make the bicycle the instruction manual on visibility? Some design suggestions for this include a sticker to remind the cyclist what steps to take for visibility, a bicycle or cycling app/computer that asks you to complete a pre-ride checklist, lights on the bicycle that react kinda like on a plane, or even an acronym to remember. Here I asked myself, how might we make the communication between cyclists and motorists a universal language like math and music? Some design suggestions for this include simple, refined signals, products that only have a single interpretation, integrated lights on the bike that react to surroundings, using haptic feedback, and 2-directional communication that is direct and closed. Here I asked myself, how might we allow the car, bicycle, and road infrastructure to communicate? Some design suggestions for this one include integrated lights on the pavement, direct electronic communication, and something in the road, in cars, and on bikes that communicates. For this one I asked, how might we design cyclist infrastructure that elicits a consistent immediate reaction? Some design suggestions for this include attention-grabbing and standardized infrastructure, blinking, bright colors, and something that interacts with the car and gives positive reinforcement. For this one I asked, how might we create traffic calming measures in wide open spaces? Some design suggestions include implementing speed bumps, giving extra passing room, including obstructions like roundabouts and tree canopies over the road, and something called realigned intersections. Next I asked, how might we provide road space with the same perceived safety value as sidewalks, but actually safer? Design suggestions include separated bike paths, reminders at driveway entrances and exits to look for cyclists such as rumble strips and color, physical separation that seamlessly integrates into intersections, and literal hierarchy where the bike lane is higher than the road. When asking myself how might we make intersections safe for turning, my design suggestions include adding rumble strips at corners to remind motorists as they turn to look, call attention to crosswalks and bike lanes with art, make it unique but also consistent so that they all have the same function but they play off of the area. For inattentional blindness, I asked, how might we help the brain decipher critical information from the rest of the chaos? Some design suggestions include creating more motion in the areas that need attention, organizing the chaos, and creating hierarchy in communication. Lastly, I asked, how might we make cyclists meaningful to drivers? Design suggestions include making cyclists more human-like, such as putting faces on helmets or a person riding a bicycle on the back of their jerseys, and always including a person in the cycling icons on the road. After all of this, I went back to the journey maps I had made of current situations for each persona and plugged in what the ideal situation would be. For each persona, you can drastically see the stress levels decrease. For the competitive cyclist, his stress levels decrease due to traffic calming, better intersections, and the ability to decipher information. For the fitness-oriented cyclist, her stress levels decrease due to the same factors as the competitive cyclist. For the recreational cyclist, her stress levels decrease due to better information, safer road spaces, and better intersections. For the commuter cyclist, his stress levels decrease due to traffic calming, better intersections, and the ability to decipher information. And lastly, for the motorist, his stress levels decrease due to simple and direct communication, consistent reactions, and the ability to decipher information. After all of that information, let's quickly recap what we covered. I successfully researched, displayed my findings, highlighted the issues, and presented opportunities for change. But what can we do with all this information, as motorists, as a cyclist, and in the local community? As motorists, we can strive to understand that the bicycle is a vehicle and that cyclists are not pedestrians. The best facility for accommodating cyclists is the existing roadway network. We can expect to see cyclists on the road, we can brush up on cycling road rules, display patience, and limit distractions while driving. As cyclists, we can use common sense while riding on the road, brush up on road rules, take a class, wear high visibility gear, focus on creating motion that makes us appear more human, and we can consider making ourselves audible to motorists. Lastly, May is Bike Month, so what better month to promote safe cycling? If you want to participate around the world, there will be rides to remember cyclists who have fallen. And lastly, you can let your state representatives know how important bike infrastructure is. If you would like any more information on the subject, I created a website that will have this presentation, my slide deck, and all of my sources available to the public. Thank you for listening to my capstone on cycling safety. I hope you learned at least one thing that you can take and implement today, whether that is as a cyclist or a motorist. Thank you.